You remember the concept of multicollinearity? What is multicollinearity? In regression we discussed that multicollinearity is nothing but the interdependency of predictor variables. Within predictor variables, some variables are interdependent. What happened? At that time, when they are interdependent, the coefficient, the final regression coefficients went for a toss. The variance of the coefficients was so high that we were not able to trust those coefficients. When we are doing individual impact analysis of, let's say, x1, x2 are related, and then when we are doing a relation analysis of x1 versus y, x2 versus y, because these coefficients are so wrong, we are getting into wrong conclusions. So then we realize that x1, x2 are related. That is called multicollinearity. We just can't keep both of them in the model at the same time. Either it has to be x1 or x2 because one of them is carrying complete information about the other one. Now if you observe closely, multicollinearity has something to do with only predictor variables. It has nothing to do with y versus x. It's all x versus remaining x variables, x1 versus remaining all x's, x2 versus remaining all x. Now multicollinearity is an issue even in logistic regression. Why? Because you're hardly considering the y variable or the dependent variable in that scenario. So if there is multicollinearity, even logistic regression coefficients will go for a toss. Multicollinearity need to be treated even in logistic regression, because even in logistic regression we are using some kind of optimization when there are variables which are interlinked within this model. Definitely they are going to impact the coefficients. Again, that will lead to wrong conclusion even in logistic regression when we are trying to analyze the impact of each variable with the y variable. So multicollinearity need to be treated even in logistic regression. Here only the relation between x and y is non-linear. That's why we use logistic regression. And the multicollinearity is an issue related to purely only predictor variables, all the x variables. Multicollinearity need to be fixed even in logistic regression as well. Otherwise the individual coefficients will be affected. And the process of identification of multicollinearity is same as the linear regression. You just need to use simply VIF value. Why it is same? Because multicollinearity is about all the relation within x variables, x1 versus remaining variables. That's how we found VIF value. x1 versus rest all variables, x2 versus rest all variables. So we just need to find out the VIF, which is derived from, indeed, when we build individual models x versus remaining variables. So we have to use VIF to find out or to identify multicollinearity. If there is multicollinearity, we can give the same treatment that we were giving like earlier. So in the fiber bits model, let us see whether there is any multicollinearity. So we need to find VIF. Any VIF more than 5, that is an indication of multicollinearity. That doesn't mean we have to drop all the variables with VIF more than 5, right? We have to drop one by one. If x1 is depending on x2, x2 is depending on x1, so x2 is redundant in presence of x1, x1 is redundant in presence of x2. Both of them will have a VIF more than 5. That does not mean we should drop both x1 and x2. We will lose out the basic information. So be careful. Multicollinearity, when you are treating it, you have to drop one by one, each variable one by one. First look, find out the VIF, go for the highest VIF. First of all, see whether VIF any variable is more than 5. Then only you go ahead and see the highest variable with VIF, you can drop that. We need to use CAR package, companion to applied regression, and then summary of the model. This is the summary of the model, and then we have to use VIF function. VIF, all the variables. Once again, VIF. Is there any variable with more than 5 VIF? Nope. Looks like all the variables are carrying independent information. Income is not dependent on month on network. Income is not dependent on number of complaints. Monthly bill is not dependent on plan changes or technical issues per month or speed test. Looks like all these are carrying pretty much independent information. If you are wondering this is near to 5, let's drop it. Nope. Let's not drop it. They are not more than 5. Even if you want to be really sure, if you want to drop it, you can go ahead, drop it. But we are going to lose out some information that might impact the overall accuracy of our model. So that's how we find out multicollinearity. Multicollinearity is applicable only when the model has multiple independent variables. It is to test whether there are any variables that are carrying kind of same information but still named as two different variables. That is about multicollinearity. Generally, one more example of multicollinearity that I can think of is why we need to eliminate multicollinearity. Why multicollinearity is also known as redundancy. I'll give you an example. You have a variable called GDP. So you are using this GDP to predict sales or to predict revenue. Now you have this variable and GDP of a country, and the variable name is GDP in dollars. That is the first variable. Second variable is GDP in euros. Third variable is GDP in rupees. It's all just single value. We are just changing the currency, that's it. We are not gaining any additional information from remaining variables. One variable is sufficient, maybe GDP in dollars or euros or anywhere, that's it. So there is no point in keeping multiple variables which are carrying the same information. In fact, if you keep like that, then you are going to really see a lot of variance in the coefficient. That means coefficients can be anything. They can vary from between anywhere to anywhere. Now that is an issue, right?